Mm. Hi, everybody. All right, if you guys can just make sure you're muted as you come in, that would be awesome. We are on our second to last Math Monday. We're going to be doing a bonus session not next week, but the following Monday, April 12th, on geometry. So tonight, Mike will be covering seminar. If you guys have any questions, as we get going here, make sure to put them in the chat. And if you could also include your name and where you're from in the chat as well, we would really appreciate that. I think that about covers it. If you want to get going, Mike.
All right, thanks, Taylor. Thanks, Aaron. Hi, everyone. Good to see you all tonight, or this morning, or wherever you're dialing in from, or watching this later. I mean, who knows? It's such a interesting world now, right? Before we get started, I have a request that will help both of us possibly. We're trying to provide a part of Math Institute's goal is outreach and trying to make as much of an impact as possible. And so doing things like these free webinars is part of that mission. We also have a YouTube channel where we put a lot of free videos, and we want to increase the amount that we're putting out there, free to use short videos about math topics or about how to work with students or lessons or things like that. And in order to make it more viable, it really helps on YouTube if we have more subscribers. And so if you haven't already subscribed to the Math Institute channel, Taylor's going to put that in the chat in a little bit. And subscribing, if you aren't familiar with YouTube, it doesn't mean that you're going to get notifications or emails. All it means is that it'll show up on your left when you go into YouTube. And if I put a new video out, then it'll be a little green dot by it. But the more subscribers we have, once we hit certain thresholds, we can do things like do polls and surveys on there. And then again, it'll help our outreach, because the more subscribers you have, then the more the videos get recommended to other people, and then it kind of feeds on itself. So that's going to really help the Math Institute grow and help us meet our mission. So if you're so inclined to subscribe, that would be wonderful. I feel like I'm doing one of those public television things where you get to watch the TV show, then like they have the pledge drive and they ask you for they give you all this talk about all this stuff before they in between the movies or whatever they're showing. So that'd be great if you can subscribe. If not, that's okay too. I won't hold it against you, but it would be very it'll be helpful to us, and pass it along to someone else if they're interested and they think they benefit from the videos. What that does for you is, in the future, we did a lot of posting of videos about 6 months ago. And we're going to start that up again. So we'd like to put out 1 or 2 videos a week just on new math topics and new things kind of like this. And so that'll keep you up to date when we post new topics as well. So it's kind of hopefully it's a win-win for everyone. So I just want to say that before we get started about the YouTube channel. Okay. So, but what I really came here to talk about tonight was Math Seminar. And Math Seminar is one of those things where whenever I do workshops with Montessori teachers or other math teachers, and we do Math Seminar, it's always a thing that's very well received. And it's one of the things I think that I hear the most back from teachers that makes the biggest impact in their class when they do the Math Seminar. And so that's really what I'd like to talk a little bit about today, what Math Seminar actually is, and how to do a Math Seminar, kind of what goes into it. And it's something that I did not invent. I actually got this idea from, I was at a math conference, and Phillips Exeter Academy, they do their entire math program. They're a private school, I think in New Hampshire, or maybe Vermont. They do their entire curriculum through kind of a Math Seminar format. And when I met with the professor from that school, he was telling us that, you don't necessarily don't want to do everything with Math Seminar, but take something from it and adapt it so it fits in with your environment and your school and what you can do. Because they developed it with a certain setup that they have and they're able to do with, they have a boarding school, they have tutors, they have all this kind of a setup to really support this. And so when I was doing work in the summer for the orientations, for the adolescent orientations, they did a regular seminar. That was a big part of the curriculum for like language and for history, reading a text and then having questions about it and having this great discussion about what students have read. And so what I've kind of done is I've kind of taken that idea of the seminar that students might be doing that's based on books or based on literature, and kind of doing something similar though, but for math. Um, so that's what I want to share with you tonight. Now, with that being said, we do math seminars on books as well. There's a lot of great books or articles that I'll bring in for the students, and we run those like a traditional seminar, like you would see in a literature class. But that's not the math seminar that I'm going to share with you today. So let me start. I have a little presentation here. Okay. So the math seminar. So the way I kind of look at mathematics overall, I think before in one of these, I've talked about the three-legged stool of mathematics that Montessori writes about, where she has algebra, algebra, and geometry as the three legs of the stool. And when we have an adolescent environment, we still have those three legs, but what kind of binds everything together? Because the idea of having a separation of algebra, arithmetic, and geometry, depending where you are in the world, I know that's in America, it's kind of a thing where you have a separate algebra class and a separate geometry class. I know in a lot of other countries, they just kind of have a math class where you're just working on mathematics, and some things are attacked by algebra, some things through geometry, and there's much more a blending of those sub-disciplines together. However, when you're studying a certain skill or an aspect, then you're generally in one of those branches. So you might be attacking something algebraically, you might be studying some properties of geometry and so on. However, when you're solving a problem, when you encounter something that you need to do or need to solve or to figure out, there's nobody telling you, well, you need to approach this using algebra or you need to approach this using geometry. For example, if students are doing they're building a garden, is that an algebra activity, a geometry activity, or an arithmetic activity? Well, at different points, it's going to be all three of those things together. And so that's a much more natural way to approach it, is through work. And so I made these three braces of the stool that kind of bind things together in an adolescent environment. And those three things are projects, history, and seminar. And I feel that those really can bring in all three of those legs together in an organic way in the classroom. So what a math seminar basically is I will give the students some questions at the beginning of the week, let's say. Maybe it's every 2 weeks, but I've done these weekly before. Maybe I'll give them some questions to work on Monday, maybe 3 or 4 questions. And the students have all week to work on those. And then at the end of the week, we come together, we sit in a circle. We'll often have a whiteboard as one of the seats, kind of. This way students can, if they would wish to demonstrate things on the whiteboard, then they'll go ahead and do some writing. And we have a discussion about the questions that they worked on all week. Now, on its face, it might not sound very impressive. It's like, well, isn't that just doing homework and then sharing your work? It's much more than that, actually. And we have some very specific goals of the math seminar, which are so critical to setting up that positive environment for the adolescent. And so some of the goals of math seminar, one of the hardest things for us to do is to get students to think mathematically. And that's not just saying, how do you solve a problem or how do you follow procedures? It's a way of organizing your mind. It's a way of coming across something that you don't know how to solve and thinking rationally. It's about thinking through things logically. It's about testing your work. It's more like a scientist would approach a problem than anything else. It's probably one of the closest analogies. And we can solve, and we're not just talking about mathematical problems. We're talking about thinking mathematically. There can be social issues that you could attack mathematically. There can be issues in your community that you can solve by thinking things through mathematically, like in a logical, consistent way. And one of the hardest things for me to do as a teacher, I can teach students how to follow directions. I can teach them a process. But how do you teach them to say, well, here's something you've never seen before, something you don't know how to do, on its face, but how do you just sit there with it and figure it out? I'll go on YouTube. Speaking of YouTube, you'll go on YouTube and you'll see, people put out like a problem of the week. I know Presh Talwalkar does those. They're pretty cool. But you don't know where to begin. You just kind of look at it and say, well, okay, here's a circle, here's a triangle. How do I find this area? I have no idea where to approach that. Do I use algebra? Do I use geometry? Do I use some sort of factoring trick? Like, you don't even know where to begin. And oftentimes for our students who are used to seeing a teacher show them, here's how you start with step A, and here's how you get to step D, and you just go through these steps. If they can't see how to do those steps, then they just give up. They feel very lost. They're just like, well, I don't know what the steps are. And that shuts down mathematical thinking. It shuts down problem solving. And kids get very frustrated by that. Instead, we want the attitude of it being very exciting to say, gosh, there's a million things I could do with this problem. Like, I don't even know where to begin. Let me just try some stuff and let's see if I can figure this out. It's kind of more like if you give a kid a jigsaw puzzle, it's like, like just start putting it together. Like you figure out the puzzle, not by looking at the whole thing. And, you don't sit there with all the pieces on the table and look at it and think for an hour and say, oh, now I see how to put it all together. What do you do with a jigsaw puzzle? You start grabbing pieces, you start trying stuff until you find things that work. And that's kind of that attitude we need in mathematics so much more, is because that's part of real life. If you're a computer programmer, if you are an engineer, if you're in medicine, if you're doing anything, there's not going to be somebody there to tell you what to do. You have to have it in yourself to say, how do I start this? What can I try? How do I begin to work? And that's really what we want to get across. And so the seminar really forces students to do that, to think mathematically. And it's a process, and we'll talk how that works, from them coming in oftentimes very shy to try things, very resistant sometimes to make mistakes or to try new things, how they can kind of get over that fear. And that really opens up so much for them when they're able to think differently. A part of this is seeing mathematics as a process, not just an end goal. There's plenty of things that we do where we want to see math as a process. When we do skill work, when we work with materials, we see it, how do I figure this thing out? How do I, follow the steps to solve this? But mathematics is so much more than that. Mathematics is really this way of thinking. It's about how do I go through that? How do I do trial and error? How do I make mistakes and right myself? How do I kind of get a feel for things? That's something where, students have to develop that through practice, where you're trying to solve a problem and you kind of get a feel for going down the right path. You don't necessarily know that until you get that experience. And to know that's okay. Again, if students only know to say, well, when you see a problem, you need to, it's kind of like when students take a standardized test, right? I think a lot of students approach it this way, where they look at the question, they kind of say, okay, what category does this problem belong in? What are the 5 steps I need to follow? And that's what I do. They kind of, it's very mechanical. And then what happens is when they come across something they don't know how to do, or they haven't seen before, or the steps aren't clear, they just feel very lost and frustrated about that. Rather than for them to be okay with, you know what, let me just try this and see what happens. No, that didn't work. Well, what did I learn from that mistake? And how do I fix that? And how do I correct that? And they have to practice that and feel comfortable with that process. Another goal is clear expression. We have kids in our classes who, will oftentimes say, well, you say, we want kids to show their work. That's a big thing, right? Math teachers always say, well, you have to show your work so I can see your thought process. And so sometimes kids will say, well, I can't explain it. I just know it. Well, but how do you express that to somebody else? How do you explain what you are thinking? And there's value in that, because if in life you know how to do something, but you can't tell other people what you're thinking, you're not going to go very far. You can be the smartest person in the world, but if you can't communicate your ideas to other people, whether it's math or not math, right now I'm not really talking about math. I'm talking about how to do seminar. And if I can't, I hope I'm expressing myself clearly, but if I can't do that, then, the knowledge that I have isn't really going to be very helpful to anybody else. And so part of our goal is just something beyond mathematics. It's just that, how do you tell a student, here's something very complicated that I have in my head. How do I then express that to other people? And how do we have those conversations back and forth? A really important goal is to encourage collaboration. One of the things that, when we run a classroom, we want to have the students have as much independence and freedom as possible. And that doesn't necessarily mean students are working individually all the time, but it means they need to be free from the adult. It means that I can't always be there with them to help them, which means they're going to have to rely on each other in a very positive way. And so when students learn how to express themselves, when they know what questions to ask, when they know how to struggle well with the work, then they're more comfortable working with each other. And then I don't have to be there all the time. They can go through that process together, and they aren't as reliant on me. And so the best part of my classroom is when I hear math seminar happening when we're not in math seminar. When I can be over here and I hear a group of students talking at a table and it sounds like they're in a seminar. They're having this really deep discussion about a problem about a potato or something silly that seems ridiculous, but they're really into it and they're arguing with each other and they're discussing it and they're really working through it together. Like that's such a positive thing to happen. And they're going to learn more from that process than any specific lesson that I could give them. It's really through their collaboration. And that's the power of the adolescent anyway, right? I mean, they're social creatures. They need to be social, and we want to have them be social in a positive way, in a way that's going to increase their intellect, increase their academic abilities, increase their thinking power, and so on. So I already mentioned, freeing the child of the adult. That's, when they can collaborate with each other, then they don't need me as much. And then I can be much more helpful, right? I can step in at the right time and give the little help that is needed. And so this allows me as the adult then to have a class that's much more diverse in age group, in ability levels, because I can let the students work with each other and I can be in more places. I can use my time much more efficiently when the students don't need me for everything. I can be there for just the things that they really, truly do need me for, and they can rely on each other and their own process too, and their own intellect. Oftentimes, kids will just look at a question and they'll say, "Well, I don't get it. I don't know how to do it." They read it once and they're like, "Yeah, I don't know how to do this." Like, I can't be there to help them through that. So the seminar helps the students say, "Okay, I don't know how to do this. What do I do now? What do I have at my disposal? What can I try?" And after a while, then they might work with their classmates. And after a while, they may ask me for some help, or I might give them some guidance. But it's not their first reaction to go to the adult for help when they don't know how to do something. That's really important. And I love the phrase "fearless learning." That I think there's so much fear around mathematics, and I see it in adults as well as students, where people have these negative self attitudes where I'm no good at this, or I'm not a math person, or they just don't ever want to make a mistake because math is either right or wrong. That's it. That's all math has ever been. You either got the right answer or the wrong answer, and that's all that's important. But instead, when we're talking about mathematics as being a process, now all of a sudden, then there's room for error. There's room for trial, and there's it's a much more humane process, and that then allows the students to take risks. It allows the students to be vulnerable, because you never really grow in life unless you're willing to take risks and be willing to make mistakes. And I think it was the local football team here in Cleveland, which they were bad for a very long time. And the coach was saying that to the quarterback, he said, "It's okay to make mistakes. Just don't make the same mistake twice. Make all the mistakes you want, but have them be different mistakes all the time." So in other words, we do want to learn, we do want to improve, but we learn more by making mistakes and then correcting those mistakes than we do by never, ever trying. And so often kids are afraid to try. Adults are afraid to try. And if we can get students over that fear of trying, then my gosh, then we've helped them so much in their lives, yet alone in the math class. And again, I feel that seminar is one of the best ways to help students with that, to get to that point where they're fearless learners. And then I have this last, because to me, it's not really the main goal of math seminar, but it's there nonetheless, is students do get a chance to revisit math skills and concepts. So they're going to be working on algebra and geometry and arithmetic and statistics and probability and exponents and factoring and all those things that we do in class. They're going to bring some of those things into the seminar. And so there are mathematical goals that we can have as well, but I always find those secondary, honestly, to the other goals that we have here. And usually when I come up with the questions, I'll try to come up with questions that students can answer with the skills and concepts that they currently know. So they don't need new math to do this work, but they might have to apply several concepts or think about what they've done in a new way. Okay. So when we have the math seminar, students come in with their notebooks. They have their work, their attempts, and I'll start off with kind of I have a typical series of questions that I like to ask the students to guide them through. And so I'm going to kind of share that with you today. And things, depending on the question, things don't go exactly like this, but I just want to give you a feel for what we would do in the math seminar. So kids are sitting around. I say, question number 1. Let's talk about it. We'd read the question number 1 together. And I'd say, so what were your initial thoughts? When you read this question for the first time, what was going through your mind? And the reason I'm asking them this is I want them to reflect on their process. Like, what did you do when you first thought this? Let's talk about that. And then I'm going to say things like, what did you find challenging? Already saying, what were your difficulties? We're bringing those out first, okay? Because we want to say that this is the space where we talk about those things, okay? And so I'm asking them kind of go back in your mind. When you first saw this and you first read this, what were some difficulties that you had? And here's what's great about this, especially if you have the pleasure of having a mixed age group, or at least a mixed ability group. But I think mixed ages is really important. So when I would do this with my 7th, 8th, and 9th graders, that would be my 3-year span for my younger adolescents. You know, the 7th graders come in, the younger students, and they're just afraid of everything. They don't know what's going on. You know, there's a lot of peer pressure that's happening here. And so for them to say, gosh, I didn't understand what a whole number was when I read this question, that's really difficult for them to do. Putting yourself out there is very hard. But if you have those older students, like that 9th grader that everybody kind of looks up to, and she says, yeah, when I read that, I didn't understand what a whole number was. I couldn't remember that at first. And she puts herself out there because she's confident and she's done seminar before, then all of a sudden, those other students look at her and say, oh, well, if she can say that, yeah, I didn't know that either. And all of a sudden then, you know, it's okay. You create this environment where making mistakes is okay and being vulnerable is okay. And when you have older students there that can model that, because they have more of that confidence, because they've been through the process before, because they understand truly what your expectations are as an adult, then that's really important. Because, you know, my expectations are not that students come into seminar getting everything right. My goal is that we have a discussion, that you've thought about the question and that you're willing to discuss what you've done. If you do that, then you're going to get a quote A+ in seminar. And, you know, the younger students, until they kind of know you, they're really hesitant about that. They're like, no, you're still going to grade me if I got it right or wrong, right? Like that's the most important thing, is getting the answer. And, you know, as we go through this process, you know, they have classmates who have done this before. They say, oh, wait a minute, he's serious. Like I didn't get it right, but I still got an A for seminar for the day. Yes, because you came in with work, you answered questions, you had the discussion, you were thoughtful in what you did. And for this exercise, that's what I'm really looking for. And so by having students be able to model that and going through this list of questions every time really emphasizes that that's what we're here to do. We're here to talk about our process, not necessarily to solve the question, if that makes sense. So then I go ahead, and the next thing I usually ask is, what did you try that didn't work? And when students come in, they usually have in their notebook, they have a question there. And then I tell them not to erase their work, their false starts, because when they come into the seminar, the goal is to share what they did. And so if they tried something that didn't work and they erase it, it's like, well, wait a minute, but you did that. That's what I want to see. And so oftentimes a kid will say something like this. Well, I tried this, but it didn't seem to work. Another student will say, oh, I tried that same thing and it will work if you just do this, which is wonderful, because all of a sudden the student then that felt like, yeah, I didn't do this right. A peer of theirs is saying, actually, you were right. You just need to follow it further. Here's how you can modify things for it to work. That's very empowering for that student. I was going to mention something else. So yeah, kids come in, they have, okay. So, you know, what did you try that didn't work? So sometimes there's dead ends. Sometimes there's things that are partial dead ends, but didn't, but actually could be modified. And sometimes students say, yeah, I just tried this and it seemed ridiculous. And yeah, I don't know why I did that. Great, thanks for sharing. But again, it opens up the fact that there's a lot of different approaches to the question. And that's really what we're trying to get at. And then after that, okay, what did you try that you felt good about? In other words, what worked for you? And this is where students start saying, oh, well, I did it this way, and here's how I solved it. Maybe that's when they come up to the whiteboard and they say, well, can I show you? And they'll kind of go through their process and they'll say, well, I did this problem this way, and here's what I did. And so we that's really great. And here's where that communication comes in, because if a student goes and says, well, here's what I did, and nobody else understands what they're talking about, then as an adult, I'm going to say, I can help with that. So I might say, can you re-explain that? Or I might ask a student, did you understand what Emily said there? And if they say, no, I don't understand, then I would say, well, what question would you like to ask Emily? So I'm trying to get them to have the dialogue. So my goal isn't to question the student. My goal is to help the students question each other, to have that dialogue. Because kids will sit there, especially if the person who does the problem is like one of the good math kids. They'll just sit back there and go, oh, okay, sure. And this happens all the time with teachers in the class too, right? Like I'll go up there and I'll do a problem. And I'll say, does everybody understand? And they kind of look at me with these blank stares, right? Because they're like, they're supposed to say yes, and they don't want to feel dumb by saying they didn't get it, right? We have to break that down. We want students to say, no, I don't understand you, whether it's a student or the teacher. Like I love it when I explain something and a kid says, I have no idea what you just talked about. Like that's so helpful. I'd rather have that than have the student say, yeah, I get it. And I know they don't understand what I said. Like we have to get them over that fear of like, well, I'm dumb. I probably just didn't explain it very well. Or maybe you need something else to help you along. I didn't communicate it well. So I'm trying to help students have that communication with each other. Well, what question do you need to ask? And then I might say to that student something like, well, can you explain what that student was doing now? Oh yeah, I understand. And I get them to have that dialogue with each other. And then after that, I'll ask, well, does anybody have a different way to do it? And this is where it really gets really fun, because a student might have done it geometrically, and another student might say, well, I did it through an algebra equation. Another student said, well, I did a check and guess table, and here's how I did it. And somebody else will say, well, I started it this way, but then I did this, and I have a fourth way to do it. So when we have a question, there might be 4 or 5 or more ways that students will have to approach the problem. And that is so important, because what that tells the students is there isn't just one way to solve a problem. There's a lot of ways to do it. And there's a lot of things that you can try in order to solve the problem. And you don't have to be just stuck with doing one thing. And students need to be comfortable with that. And that's really, that's a very powerful thing for them to see happening in the classroom. And then I'll ask, are we ready to move on? And this question really bothers the kids, because they'll say, well, what's the answer? And I'll say, well, you just had 5 people explain it 5 different ways. I won't say this sarcastically, but I'm thinking, I'm like, well, you just had 5 people explain it to you. Don't you know what the answer is by now? And they'll say, well, yeah, it's got to be 90, right? Isn't it 90, Mike? And I'm like, well, is it 90? They're like, well, I think so. Like, isn't it? I'm like, well, if you're not sure, then we need to keep discussing this. And in the seminar, I will never tell them if it's the right answer or not at the end. If it's wrong, or if they get 2 different answers, they can't agree, then that's the discussion. How do you know when you're right? And I think this is a huge thing that leads, we have a lot of math anxiety from students, right? We hear about math anxiety where students take exams and they kind of freeze up. And part of that freezing is because they're so used to having somebody tell them if they're right or wrong. There's answers in the back of the book, or they get a grade from the teacher. Now, all of a sudden, you're on your own in a high-stakes situation, and you put down an answer, and you're like, well, I don't know if this is right. But in the seminar, what do? You say, well, I think this is right because we did it this way, and this way, and this way, and it'd be very unlikely for 3 different students to do it 3 different ways, come up with the same answer. So that's probably right. So then when they're doing their exam on their own, they're like, well, okay, I got this answer. Let me try to do it a different way. And they try it a different way. And they say, well, I got the same answer. That's probably right. And they have more confidence in their answer. Even for students to find one way that it's right. Like, why is this right? Oftentimes students don't even ask, is this right? They just do the problem, write down the answer, they don't think about it. But just the fact that, hey, I have an answer, let me see if that actually makes sense. Is that a reasonable answer? Is what I did, is what I did logical? Does it make sense the way I approach this question? And so doing it through the seminar in a safe environment with peers and having a nice, slow, long discussion about these types of questions, that transfers over then to when the students are working on their own. That they can rely on their own wits. They can rely on their own logic to understand if they are right or if they're wrong, or at least if they're reasonable about things. And so that self-evaluation of work is something that so often doesn't happen in a math class. Where a kid will do a problem and they'll get an answer, and the answer is just like, it can't possibly be right, but they write it down because they're just going through a procedure. And the best example I can have of this is 1/2 plus 1/3. If you add 1/2 plus 1/3, if a student says 2/5, they add 1 plus 1 and 2 plus 3. They just add across and get 2/5. If they're thinking about that, there's no way that could be the right answer, because 2/5 is less than 1/2. And if you have 1/2 plus 1/3, it's got to be bigger than 1/2. So I'll tell my students, I don't care if you don't know what 1/2 plus 1/3 is, but don't say it's 2/5, because that shows you're not even thinking about things. Like, I want you to think. And so that kind of evaluation is something that can come out through the seminar. Okay, so a couple things that, again, about seminar. I'll give students questions that generally we'll be able to have a discussion about, questions that will have several different ways to approach them. Those are the best kind of seminar questions that we have. And then when students come to the seminar, if they come to a seminar in a literature class, they usually have to have like an evaluative question, an interpretive question, and maybe take some notes. And this is how you know they're prepared for the seminar. They've done the reading, they come in with some questions. For the math seminar, they have to have something written down for every question. That's their ticket in. I don't care if you get the right answer. I don't care what you have written. You have to write something down. And that shows me that you've thought about it. Sometimes I'll have kids that come in and say, well, I thought about these questions. I couldn't get anywhere. I didn't write anything down because I couldn't solve it. Like, but if you were thinking, then write down what you're thinking. It's kind of like when you're a writer and you have writer's block, right? They say, just write something on the paper. Just get it out there. We have to have that same approach towards math. Just get something written on the paper. And if you've done that, then I know you've thought about it. And now you're prepared to have a discussion about what you've done. Because nobody really cares about these problems. I'm sorry to say it, but like, these are made up problems. They're things about, I mean, some of them are they're interesting, of course, but like, if you're taking gallons of water and pouring them with different sized jugs, or you have, I'll show you there's a sack of potatoes that are sitting out in the sun, or there's a bunch of lockers in a locker room. Like, these are things that don't have any, that if I just showed the students, if I just told you, here's how you do the problem, you'd be like, okay, that's great. But when students work on this for a week and they struggle with it and they try, then they come to the seminar, they can't wait to discuss these. They want to hear the answer. They're open to these new ideas, and it becomes very powerful. So let me do a couple examples of some seminar questions and talk a little bit about how students work through these. So here's a nice one. How many 2-digit whole numbers contain, I can't see what that says there, to say contain no zeros and no more than 1 1. And so when I go through these questions, what are your initial thoughts? Well, it seemed pretty easy. Kids will say something, it seemed pretty easy at first, and so I didn't have any worries about it. Great. Did anybody find anything challenging? And that's where we have discussions like, well, I wasn't sure what it meant by whole numbers. Like, does that mean negatives? Like, what does it mean, a whole number? So now we're talking about those definitions, what that means. And somebody will say, well, what about 2-digit? Because like, I know like 15 is a 2-digit number, but like 9, you can write that as 09. So if you wrote it as 09, like, does that make a 2-digit number? Like, we had having these types of conversations. And a student might say something like, well, no more than 1 1. Like, what does that actually mean? They might say, well, I had a hard time understanding that language. Like, no more than 1 1. That's the same thing as meaning it has 2 1s in it. So they kind of discuss that part of the process. And it's going to be different for every question. So what did you try that didn't work? And a student will say something like, well, I was going to list all the numbers from 1 to 100. And I said, that's going to take way too long. So I stopped before I got the whole way there. Great. Because you could simply just write down all the numbers from 1 to 100 and cross off the ones that don't work and then count what you have left. Like that's a way that you could solve it. But you didn't want to do it because you thought it would take too long. Great. What else did you try? And so we kind of go through some different things. All right. So what did you try that you felt good about? And this is where students start to share their process. So for this one, students generally try it two different ways. One way is by counting all the numbers that meet the requirements. And a second way is students will then take away all the numbers that don't meet the requirements. And it's interesting that you can think of it both ways. So some kids will say, well, they'll start off with their list and they'll say, well, 12, 13, 14, 15, 16, 17, 18, 19, and then 20 and 20 doesn't count. Then they have 21, 22, 23, 24, 25, 26, 27, 28, 29. And they'll write those out. And then they'll do the same thing for the 30s. And they'll say, wait a minute, for the 20s, I had 9 numbers. For the 30s, I have 9 numbers. And then they just kind of go dot, dot, dot. And they kind of imagine what those next lines would look like. So instead of writing out all the numbers, they start doing it. And then they see the pattern. And they simply count all the numbers they want. Other kids say, well, I know there's so many. They'll say, well, I know there's so many numbers from 1 to 100, or I know there's so many 2-digit numbers. They'll count that. And then they'll take away the ones that have zeros and take away the ones that have more than 1, 1. And they find that way faster. But even with that, like I said, some kids will just figure out the 2-digit numbers. Some kids will take all the numbers from 1 to 100 and subtract everything they don't want away. So when you really start asking them exactly what they did, you're going to find there's several different ways to approach this. And what's important is that the kids see that in each other, that there's not just one right way to do this problem. And so I'll ask, does anybody have a different way? We'll share those. And then when we're done, are we ready to move on? Says, well, what's the answer? I don't know. You tell me, what's the answer? What do you guys agree it is? Well, we think it's 80. Okay, great. Do you want to talk about it anymore? Let's move on. And then we go on to the next question. And I really emphasize that I don't give them the answer, because as soon as I do, then it becomes about the answer. We lose the emphasis on the process. The other thing is that the answer, if the kids want to discuss the answer, that's fine, but it's the last thing that we do. And sometimes we have to force that to the end of the conversation, because if a student's been working on the question and they see, if we start off by saying, what's the answer? And they say, oh, the answer is 80. All of a sudden, then the thinking stops, because they're like, oh, I got 80. I guess I'm right. Let's move on. Because then all of a sudden it becomes about the answer, not about the process. And then all that great discussion about the procedure, about what they did to get there, is lost. I want to share one way that a student came up with this one, which was different than everybody else in the class. He thought of this actually geometrically rather than arithmetically. And so what he did was he just drew this on the whiteboard really quickly. He said, well, I imagined a grid of all the numbers from 1 to 100. And he didn't draw all this, he just kind of drew a general grid like this. He didn't count all the squares out. And here's what he was imagining. He was imagining the numbers 1 through 100 there, okay? And he said, well, here's where all the single digits are. So if I cross those out, and then all the numbers that have a 0 in them are along here, so I'm going to cross those out. So instead of having a 10 by 10 grid, I have a 9 by 9 grid. So that means there's 81 numbers there. And then 11's right there, and that doesn't count. So I threw that away. So I have 80. So he didn't actually count row by row by row. A lot of times kids will say, well, I had a row, I have 8 numbers plus 9 plus 9 plus 9. They'll add a 9 up in each of those rows and do like 9 times 8 is 72 plus the 8 from the teens, and that's how they get 80. But this kid did it geometrically, and he just kind of saw that's what the answer was. And he had a lot of confidence that his answer was correct. And if I said, well, how do you know that you didn't miss anything else? He could explain why that was correct. And so as the adult, I might ask that if need be. So, well, how do you know you're right? And the goal is for other students to corroborate and give evidence and say, well, that sounds reasonable, but how do you know you didn't miss something? And it's, again, getting them to think about these questions in a deeper way. So I just thought that was a neat way to think about that one. Here's another one where I learned a lot from my students. This question says, last year, 3/5 of the 80s club were girls, but this year the number of boys doubled and 6 new girls joined. There are now as many boys in the club as there are girls. How many members did the club have last year? And, when we first read this question, I mean, it's just like blah, 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 words, typical story problem. I don't even know what it's saying here. And we acknowledge that. We're like, yeah, what do you do when you come to a problem that's just like a word salad where you don't even know what it's saying? How do we break it down? So I'll say, okay, so when you saw this the first time, it was just a big mess to you. What did you do next? How did you think through it? How did you break it down? Where do you begin? And so some students are just lost. They look at this and they start crying, like almost literally. They're like, I can't do this. But when they hear their classmates say, oh, well, first I did this, and they need a strategy of how you start this. So you just don't magically know what to do with a question like this. But hearing other people about what they did when they first saw this, what they tried and what didn't work, that's giving everybody skills. This way they're prepared the next time. Okay, so as I mentioned before, students have to have something written down. And for this question, it was very early on in doing math seminar, and the kids were very frustrated by this question. I had some parents that were upset because they were like, this problem was way too hard for my 7th grader. How dare you give him questions he's not prepared for? And it was really like, and the parent will say something like, we spent an hour working on this together last night. I'm like, you shouldn't spend any time working on this. Like, they're not going to be, because the parents are like, well, if he doesn't know how to do this, he's going to fail math. And it's like, that's not what math seminar is about. It's about talking about our process, about how do we think through this and what are we going to learn from that. And so I should have done a better job educating the parents ahead of time what math seminar was, because a couple parents were just not pleased that I was giving them such a difficult question. So anyway, kids had some algebra. A lot of kids had some algebra equations written down, some other things. But I came across one young man, and this is all, for all the consternation for this problem, this is all he had written down. And that was his solution. And 30 is the correct answer. And so I said, okay, explain to me what in the world you did. So let's look at the question again one more time. I'll just give you a second of silence just to read it one more time. And it would be great if we had enough time for all of you to like work through the question, because then right now you're kind of looking at it and saying, well, who cares about this question? And when I show you the solution, it'll be cool. But if you struggled this for like a half an hour on your own, then you'll appreciate this solution like a million times more. And I think this summer, I'm doing a workshop on all the elements of the classroom, and seminar is going to be one of those. And so during that time, if you join that, we'll actually do a seminar together. So I'll give you some questions to work on, and we'll actually do a real seminar. We'll do it virtually, of course, but I'll actually go through and model exactly how I would do it, and we'll get that interaction. You'll see how that works. So here's what he said at first. 3/5 were girls. And so he just basically drew a rectangle and divided it into 3/5. He saw that fraction, like physically. So 3/5 were girls. The next thing it said was the number of boys doubled. So right now there's 2 squares that represent the boys. So if the number of boys doubled, there'd have to be 4 squares. And then it said 6 new girls joined. But now the amounts were even on both sides. They were equal. There's just as many girls as boys. So there are 4 squares for boys and 3 squares and a 6 for the girls. But they're even. So they both should have 4 squares. So if they both had 4 squares, that means that extra girl square has to be worth 6, meaning that all the little squares are 6. And that original strip then is going to be 30. And that was brilliant. Just saw it and did it pictorially. When the kids who spent all the time doing the algebra equations saw that, they were like, oh my gosh, that was so easy. Why didn't I do it that way? And then the kids shared their algebra. And what they realized as they did that was they were actually doing the same thing, but they didn't have the visual for it. So when they set up the equation, they set up something like, 3/5 x plus 6 equals 2 times 2/5, whatever. They were doing the same thing. But once they saw the student do this visually, they understood their algebra better because now it actually had context to what they were doing. And the student who did this way was now looking at the algebra, which he didn't know yet. But he was watching the algebra and saying, oh gosh, well, that's the same thing I did. They're just doing it with symbols instead. And so, I always ask the kids to take notes during the seminar as well, because you might see something that you feel like you could use later that might help you out more. And so that's what was happening. They were kind of taking notes from each other and deepening their knowledge through this kind of question. And so the student who did this never thought themselves good at math. And all of a sudden now the whole class is like amazed by the work that they did. Just totally does wonders for the kids' self-confidence, for their ability to try, to have that fearless learning. Really great things can happen during the seminar. I'm just going to go through a couple more quick examples here just to show you the types of questions that really work well in a seminar. Ann and Bob take turns in a game. Sorry, I'm going to have to just get out of this for 1 second because I can't see anybody. I can't see the whole screen. Ann and Bob takes turns in a game. At a turn, a player takes 1 or 2 coins from a cup that at first holds 6 coins. The player taking the last coin wins. If Ann goes first and both play perfectly, who will win and why? And there's all kinds of series of games like this. If you want to research it yourself, it's called NIM, N-I-M. There's all kinds of games where you have a certain amount and you take different amounts away. And you try to win the game by either holding the last coin or by taking by forcing the other person to take the last coin or the last whatever it is you're taking away. The question the students have the biggest discussion about is, what does it mean to say when you say play perfectly? Like, what does that phrase mean? And it's something that's very difficult to explain, but it's essentially this, is that if you could see ahead to all the possible moves and there is a winning path for you, then you would take that winning path. In other words, you don't make any mistakes that would hinder your winning. So if you're playing tic-tac-toe, for example, and you have 2 X's in a row and it's your turn, like the winning move would be to put the X in the third, put the third X there to win the game. Like if you don't do that, you had an opportunity to win, but you didn't take advantage of it, you're not playing perfectly. Likewise, if there's 2 X's in a row and you're the O's, you have to block that spot. And if you don't block that spot, you're definitely going to lose. So if you didn't block it, you aren't playing perfectly. So for some games, you can play perfectly and still lose because there's no way for you to win if the other person does what they're, quote, supposed to do. So we have this great philosophical discussion about it, and then we see the students' methods. Some of them did tree diagrams for this to show all the possibilities. Others actually played the game. And then they said, then we expand it and say, what if you had 7 coins? What if you had 8 coins? And then all of a sudden, there's this whole theory about games like this that the students can explore and discuss. Here's the potato problem I've been talking about. I'll just give you a second to read this one here. I really like this question because the answer is very counterintuitive. Oftentimes when students read this, they'll say, oh, I thought it was going to be really easy at first. I thought it was very obvious, but then I started thinking about it more and it became really difficult. I solved this through a diagram. A lot of people choose to use algebra to solve this. There's a lot of different ways to approach this. And again, where do you start? There's no right place to start. And that's what we discuss with these kind of questions. Here's a logic one. Each of the 4 cards shown has a letter on one side and a digit on the other side. Now read the sentence below. Whenever there's a vowel on one side of the card, there's an even number on the other side of the card. So the students have to identify every card you must turn over to determine if the sentence is true. And so again, a lot of discussion and debate about what that actually means and why. If students know formal logic, then it's a very, quote, simple question, but most students don't know that. And so this can serve as an introduction to something new to them but we never have to do formal logic. We can just talk about what does it really mean? What do definitions mean? How do you know that something is true? What's essential here? But again, these kind of questions, while they might involve some algebra or some geometry, the goal is for them to have a discussion about what they thought and how they go through that process. And then that helps to meet those goals in the end. Last example, which is larger and why? This used to be a great question. And then I had a kid come in and said, well, I just went on Google and typed it in. And because if you have a calculator, back when I did this question, you had a calculator, it only goes up to like 9 digits or 10 digits. You can't actually do this. But kids can put this now on the computer and actually see which one's bigger. So the why is just like, well, because I saw it. But so now I modified the question to say, well, if you didn't have a calculator, how could you determine which is larger and why? So we might want to modify some of our questions just to be, to be more. And again, kids kind of know what the purpose is. So just quickly, math seminar rules: students have to write something. That's my biggest rule, and they can write anything they want to. What did you do to solve it? Just give me a written explanation of what you've done. Make a diagram. I'm a big diagram person in math. I always start with a picture or a diagram. Make a table of data. Estimate it. With that boys and girls 80s club problem, like you can just check and guess it. If you don't know how to do it, if your life depended on it and you had like an hour, you could just sit there and just guess the answer and eventually you'd come across the right answer. So if you need to do it, you can do that. And there's nothing wrong with that. Hopefully when you're guessing though, you're not randomly guessing, you're seeing some patterns and you'll say, oh, wait a minute, here's a way I could find it quicker. But, start by doing something. And, if a kid gets really stuck, then just restating and formulating their own question. Sometimes they don't really understand the question. So if they can come into seminar, at least saying, well, let me see if I can understand what the question is saying. And they try to reformulate it in their own words. That oftentimes leads them to a way to possibly solve it. And then besides that, we follow normal seminar rules of grace and courtesy. We don't raise our hands. We speak to ideas. We don't criticize other people. We talk about the ideas that we're sharing back and forth. And it becomes a very civil, a very beautiful conversation when eventually then I can sit back and just watch the students have these discussions. So my job in leading the seminar is to stimulate conversation through questioning. I always ask questions of correct and incorrect answers. It's always great when students come in and they're like, oh yeah, we got this. And they have an answer. And then I ask enough questions and then they think that they're wrong. And then I ask them more questions and they realize they were right the first time. And they say, why did you tell me I was wrong? Like, I didn't tell you were wrong. I was just asking if you were sure of what you were doing. But, but that's, again, they have to build the confidence in themselves. My job is to elicit alternate methods and answers. So not just to say one person said it, we're done, but I try to bring that out for the students. I try to involve all the students. And I don't call out on students during the seminar. I think that's really important that we don't do that. We don't put kids on the spot. We don't want to embarrass them or make them feel insecure. But if we notice students aren't being involved in the seminar, then what we can do is we can meet with them outside of the seminar and help prep them to maybe ask a question or to be prepared to make a statement or, hey, on these 3 questions you worked on this week, do you feel comfortable sharing your method with one of those and doing some work ahead of time to get students more involved? My job is to clarify points. So if a student is saying something that doesn't make sense, I'm not going to substitute my words in. I'll say, here's what I hear you saying. And I'm going to model the language for that student who's trying to do the explanation, while at the same time, then the other students who are listening are understanding what that kid said. So it's almost like I'm an interpreter in a way. But my goal, though, is to help the students to be able to have those conversations themselves. So even if what the student is saying is wrong, I'm going to still try to say it in a way where it's their ideas. I never substitute my own ideas in. And really trying to be positive, accepting and validating all their attempts. There's usually something good in anything that anybody tries. And so especially for kids who are more new to this, who are maybe a little weaker in math, or they feel they're weaker in math, who are more hesitant, building up their confidence is huge, because once they make that breakthrough, which sometimes doesn't happen for a while, maybe it's a half a year or a year until a student really feels comfortable and confident. But once you break through that, so much good can happen. And until kids break through that, it's really, really hard to make progress. So things I try not to do is to be the final word or turn my discussions into lectures. I don't want to hijack the conversation by all of a sudden teaching a lesson on factoring, or teaching on how to set up an equation or how to do unit conversion. Like, that's not the time. If students don't know how to do that and nobody knows how to do it, then I'm going to make a note for myself and I'll teach the lesson later. I'll do that next week, but not during the seminar. It has to be their space. It has to be a place where they don't look to me to rescue them. They're having the conversation. And if they don't get anywhere, if there's a problem where they don't know how to do it and we don't solve it, you know what? Then we don't solve it. Oh, well, we can come back to it later. It's not the end of the world. There are unsolved problems in mathematics to this day that people have been working on for thousands of years, for hundreds of years. It's okay if we go until next week until we finish this one up. And I think having that friendly attitude towards math, where it's not pressure to get things done. It's not it's not a place where it's just for a few students who are really good at it. It's really for everyone, and everybody has something valuable to contribute and to add to it. Seminar is just a beautiful place where all that can come out. So I'm going to stop there and see if there are any questions or comments. And I know some people on the call, you might have tried seminar before. I'd love to hear if you have anything to share from that. So I'm just going to stop here and open it up to questions or comments. So where do I find the questions? Yes. Okay. All kinds of places. First of all, Phillips Exeter Academy. If you go to their website, they have their entire math curriculum for free available. Now, I don't use all their questions, but I can definitely find some questions here or there that make really good seminar questions. And that's all, it's a great free resource. I have books here in Ohio. There's Ohio Mathematics League. It's a math contest, like a monthly contest. And after so many years, they publish all their problems. So I'll use some things from there. I'll use brain teaser books that I'll buy. Going online and just finding interesting questions. Really, you can get them from textbooks. Sometimes there's great questions kind of in there's the A question section, the B section, then the C section that gets kind of interesting. You can pull something from there at the end. I think some of it's just trial and error, finding questions that work really well. The worst questions are the ones where kids say, yeah, they all solved it. They all solved it the same way. And there's no discussion. That's fine. We just move on from that. But I'm like, okay, next year, maybe that's not the best seminar question, because the idea of the seminar question is there's something to discuss there. It's kind of like the difference between, if you're doing a literature discussion, good literature, the best discussions are when things are open to interpretation, right? When it's like, what was the meaning behind Heathcliff's ghost in Wuthering Heights? What was the symbolism behind that? And everybody can have, based in the text, they still say, well, here's the reasons why I think the author meant this. But there's a conversation that can be had about that. It's different than, reading a technical manual and asking questions about it. It's like, well, there's nothing to really discuss with that. So that's the thing that make the best types of seminar questions. And I think I've been collecting seminar questions myself as well. I've been trying to put together a resource for all of you for seminar questions as well. So that's something that's ongoing. So maybe next year sometime, I'll have a list of good seminar questions for middle schoolers as well. But in the meantime, I just grab things from anywhere I can find them. So.
And Mike, one of our participants, Tony Evans, put a link in the chat as well for the University of Waterloo. So
very cool. Yeah, in fact, I'm going to type in Phillips Exeter Academy as well, because that's, I think it's one, if you Google it, you can just go right to their
two L's.
Webpage. And
yeah,
it's 2 L's. I always get that. Well, there's 2 ways to spell Philip, so I don't know.
I'll grab it.
Thanks.
This is great.
And sometimes, I like putting questions in that like the kids can't solve. Like every once in a while, there's like a crazy hard question, and I don't expect anybody to come up with the answer, but it's just like, I just want to see what they do with it. It's about getting that conversation going, getting them to really think through things. Yeah, so it's really cool. Yeah, thanks for sharing, Brooke. That's great. Logic grids. Yep. Yeah, and in fact, I like giving some of those where it's like there's different types of problems and questions you can ask where it's like you have to kind of fill those in. Yep. Do the check marks and do all the cross work and everything like that. Yeah, there's so many fun things, and you never know what's going to catch on. I think Sudoku is also a fun thing to do for that as well. Like, not that they have to solve the whole thing, but to say, here's a puzzle that's partially solved. How do you know that this number's got to be 5. And for sometimes it's really easy, but other times though, it's like, man, you got to like think logically, like through a lot of different steps. And so, just anything you can find that would, again, stimulate discussion with the students is great. And sometimes those questions turn into projects. Like I said, with the NIM game, with the 6 coins in the cup, like kids got really interested in that one year. And all of a sudden then they try to develop a rule that no matter whatever number you had, you could always figure out how to win the game, whether or not you want to go first or second, based on what all the rules were. So if I change the number of coins, change the amount that we can take, and change who goes first, what's the optimal way to always win that game? And it took them like forever to do it, but they were just having so much fun with it. It's really cool how sometimes these seminar questions can lead to larger projects and bigger work for the students.
All right, nice job, Mike.
Last thing, somebody said about 3 problems. Yeah,
hour.
3 to 4 problems a
Yep.
seminar. I think we have to do seminars regularly. Otherwise, they kind of lose the momentum. I know a lot of schools, I think the best way is either once a week or once every 2 weeks. I think if you do them, you don't need to do them more often than once a week. But if you go 3 weeks in between seminar, then, the questions are out there too long. Kids kind of forget the routine of what to do. So, it depends again on how long we have for seminar. So maybe 4 questions. I always like to give more questions. Maybe I'll give 4 or 5. And if we don't have enough time in the hour to discuss them all, then they just go to the next time. Like that's fine. So you get a feel for it after you do it, depending on your time frame. But yeah, start off with 3 questions at first and just see what happens. It's really fun to do. Thanks, Cesar. There's another brain teaser book in there. Awesome. Okay, so Aaron says that it'll be on the YouTube page. So if you want to watch this again or just watch parts of it again, that's great. And while you're there, if you want to subscribe to the channel, that'll help us grow, and it'll be really wonderful for us. So, and then we can stay in touch more. You can see what's going on, and new videos that'll come out. You'll have access to those. So, thanks so much for joining. Thanks for all that you do with your kids.
Thank you, Mike.
Yeah, I really appreciate everything. So nice to see you all. And as we're gonna do another one of these in 2 weeks again. So about the importance of geometry. So we'll just keep this train going. And again, thanks for spending a whole hour of your day just to learn about some math for your kids. So it's awesome.